Hi, this is a quick introduction to the measurement of CBD and THC, and we're going to discuss the use of chromatography, mostly high pressure liquid chromatography, but some of the discussion using gas chromatography is equally applicable. And we're going to really demonstrate or discuss how FoodSense, which is a lower cost, faster way of measuring CBD and THC, can be really equivalent to using HPLC. So first of all, let's sort of dig into this a little bit, a bit more. So FoodSense is used for measuring complicated samples like chili sauces at the moment. In chili sauces, it measures a molecule called capsaicin. If you look at capsaicin and you look at the structures of CBD and THC, you can see that they're fairly similar. Now, the problem at the moment in the sort of industry of CBD oils or growing hemp is that the chromatographic methods, be it gas chromatography or high pressure liquid chromatography, they're expensive to perform. Not everyone has an HPLC, and even if you do own an HPLC, it's still a lot of upkeep on these machines. Now, if you have a sample and you send it out to several labs, you can actually have several different results coming back. So there's an inconsistency between different labs. And growers of hemp, for example, they know this. I've heard that anecdotes that, they get different results from different labs, and they basically choose the result that's best, that keeps them legal in some ways. Now, people do have historical data from chromatography, so you don't, when we talk about translating people over from doing chromatography to using FoodSense for the detection of CBD and THC, the method that we have does allow them to look at their historical data and then to compare it with the new test data and sort of have an equivalence going forward. Now, in terms of HPLC, it's worth saying that at Zimmer Pigott, we do own the high pressure liquid chromatography. This is a picture of it. We have a robot system, and we can load up the samples and we run it as a service. So we do understand HPLC and we do like the benefits of it, but we do know that there's something wrong in the industry because if you take CBD and test it at different labs, you will get different results. And the root cause of this, or one of the problems, is that there is no internationally recognized procedure for measuring CBD and THC in samples. Now, the lab of the Government Chemist in the UK made up a 1% sample of CBD, and they sent it around to 30 different labs. And these are the results that they got back. Now, what this says is that some of the labs were in about plus or minus 10%, accuracy. So they had an error of about plus or minus 10%. Some of the labs were over reading the CBD by about 20%. And some of the labs were under reading the CBD by about 20%. One of the labs was over reading the CBD by 40%. And some of the labs were reading the result in the range minus 40% to minus 100%. At minus 100%, they were essentially measuring CBD at half the concentration that it really was, which in some ways could mean if your product or the price of your product is based on the CBD content, then it's not as appears as not as valuable as it really actually is, but that's quite a range, in terms of errors from 40% to minus 100%, and only the minority of labs were within sort of plus or minus 10% of the actual results. It's a similar story with THC as well. Now, the issue with THC is that in many localities, the number that you require is about 0.2% of THC by dry weight. You have to be under that number in order to be legal. Now, the problem is if you're measuring your samples by HPLC, for example, the lab of the Government Chemist sent out about 31 samples to 31 labs, and they actually got a range of errors from 65% down to minus 100%. Really, and it's a bit more severe than that because in fact a good minority of them were under reading the THC. And what this means is that if you've got a product that's let's say 0.19% THC by dry mass, you could be standing a good chance that in fact it's over the level, and in fact the crop is legally illegal at this point. Now, what that means is you could you could have your certificate of analysis from your lab saying, what the percentage was. It could be effective in error. If the police, take a sample, send it to their labs and get a different result that says it's over, then you do have a sort of an issue on your hands. So it is more, this known error between labs is more of a concern when it actually comes to THC. And anecdotally, if you speak to a grower of hemp, for example, they will tell you, look, I sent the same sample, to different labs, and actually I got wildly different results. Now, they often blame the samples themselves, but in fact, it is part the sample, is actually in part the labs as well. Now, what people think with HPLC, is that it's actually accurate and precise. The reality is that probably in the lab, it's probably precise, but it's not necessarily accurate. Now, the situation might be that, in fact, some labs are neither accurate, or they might be accurate, but they're not precise, or worst case, they're neither accurate or precise, and that's the sort of worst case scenario. Now, other concerns with HPLC, it is expensive, which you already mentioned, and it does take a lot of effort in order to prepare a sample for HPLC, which is part of why it seems quite costly to test for CBD and THC by these chromatographic methods. Now, FoodSense is a much simpler system. This is an image of it. That's the actual FoodSense box itself. There's the sensors and there's the app. This is much more akin to, let's say, a glucose sensor. Now, each lab will have historical data. So when you try to then, bring in a new analytical system, say, I have this small, essentially box, and, we can measure CBD and THC using these disposable sensors. Of course, there's historical data, so you need to end up being consistent with that historical data. So let's talk about how we can validate FoodSense for measuring CBD and THC. So what we do is this. We take a sample. We test the sample in two ways. We test it on the ZP sensors, and we test it either internally on HPLCs, or we send the samples out to an external provider who tests the sample by HPLC. At which point now, we have two data points, or we have a set of data from the sensors, and we have results from the chromatographic testing. Now, we can use this to train, and we use a system called Julie. Now, I will discuss this in much more detail on the next slide, but same sample, tested twice on two different systems. We bring the data back together in an online cloud system called Julie, where we essentially validate. We try to make sure that the two results are consistent with one another. And if they're not consistent with one another, we keep on what's called training until we actually do become consistent, at which point then we can implement. So when adding the FoodSense to your CBD and THC testing strategy, there's essentially a training phase and then an implementation phase. Now let's talk about that training phase. So in training mode, you have a low-cost sensor like this. You put it into the FoodSense meter at the front here, and onto it you put a liquid sample of your, which probably has THC and CBD in it. And you also have an HPLC result for the same sample as well. So you send it out to the lab, or you do the testing in your own lab. It's probably worth saying that the test on the FoodSense takes about 2 minutes, which is much, much faster than sending tests, either sending the sample out to different labs or even doing the testing in your own lab. Now, what happens is with the FoodSense is we have an app. The app is on your smart device, or your Android rather. That Bluetooth connects to the FoodSense box. It runs the method file. The data comes back to the app, and then the app uploads the data to a cloud database called Julie. So we get the raw data into the cloud, and we probably have signals that are proportional to concentration. Now, what we're doing here now is we've also got the same, let's say, same samples with the HPLC results. So we have results from the sensor and we have results from the HPLC. And the next phase that Julie can do is actually, it ends up working out a correlation between the ZP sensors and the HPLC results. You want the two, you want, whether you do it by the FoodSense or whether you do it by HPLC, you want those results to be the same. Now what we do is, if they're not similar enough, there's like an offset or the gradients are different, we the Julie database actually goes back and re-examines the data and iterates, and it keeps on iterating until the results are equivalent. So if you get 0.2% by HPLC, then it's also trying to make sure you get 0.2% by the sensor. Similarly, if you've got 0.15% by HPLC, you also want 0.15% by the sensor as well. So it's iterating, doing the data extraction until it gets good correlation, at which point then it's good and it's essentially done its training and it's ready for implementation. So the implementation mode. So the first phase of transitioning, or I would say using the FoodSense to test CBD and THC in your samples, is the training phase. And once that training is done, we essentially have a calibration, and that calibration is saved in Julie. So that means when you now use Julie in implementation phase, you put the sample onto the FoodSense sensor. The app runs. The app sends the raw data to Julie. Julie uses the calibration from the training phase, and you get, for example, a result of 0.2%. And then the Julie cloud database sends the result back to the app, and you have it in the app as well, 0.2%. So now you have both a saved result on the cloud, which you can log into and look at, and you also have it in real time back on your Android device as well. So if you have any questions about the use of FoodSense for the measurement of CBD and THC, don't hesitate to contact us at Zimmer & Peacock. And it's probably just worth reiterating that what we're doing is we're doing two phases essentially. The first phase is a training phase where you train based on what the HPLC results are. And then there's an implementation phase where, having taken that training, you implement it back into Julie, and then you can go forward from there, knowing that your historical results from HPLC will then be equivalent to your new results from the FoodSense. And if you have any questions, please contact us at Zimmer & Peacock. Okay, thanks very much.